Hi friends, in this video we're gonna see how an instruction cycle works in a computer. Basically, whatever program we write in a computer is set of instructions. So computer allots a cycle of time for each and every instruction to decode the instruction and complete the procedure. Whatever instruction is present, that is subdivided into four types or four parts. First one is fetching the instruction, second one is decoding the instruction, reading the effective address if indirect address is present, then executing the instruction. Once it performs all the four operations, then again it goes back to fetching the instruction. So this process continues until a halt instruction is given. Until this instruction is given to the computer, this process will be going on continuing. So as we are seeing how instruction cycle works in a computer, first we will see how fetching and decoding is done. As I already mentioned, it allots a certain timing cycles for each and every instruction. Fetching is done or started at T0. The address on the program counter is transferred to the address register first. So when we see the control bus of the computer, we see that only AR is the register connected to PC, connected to the bus. So whatever operation we do, we need to definitely transfer the information from PC to AR, from there to register. Right? So I transfer the address from there to address register at T0 time period. Then at T1 time period, I transfer my memory in that address location to instruction register, and again I'll increment my programming counter. I increment my programming counter so that here the instruction is fetched into the instruction register. That means that instruction is completed. I increment my program counter so that whatever be the next instruction, that will be fed back to programming counter. That address is again given to address register, and again it comes to instruction register. So whatever instruction I have got here in the instruction register is decoded through 8 decoders, D0 to D7. Right? My instruction register is 12 to 14, the address register is from 0 to 11, and I is indirect or direct addressing mode. This is specially shown in I flip-flop. Okay, this is the 15th bit. My 12 to 14 bit are instruction bits, 0 to 11 bits are my address bits, and I is indirect or direct addressing bit. It is the 15th bit. So my decoders are D0 to D7 decoders. There are 8 decoders. This is the way I decode my instruction. This is the flow chart that showing the type of instruction we are decoding. Right? Now we'll look into it. First, SC is set to 0. Right? Then my program counter, I am updating my address register with my programming counter address at T0. At T1, my memory, whatever memory in the address register is given to a instruction register, and thereby incrementing the programming counter. At T2, I am decoding my op code. I am decoding my operation code. Okay. After that, my D7, the rest of the type of instruction is determined using D7. Okay. So now when D7 is 0, the output of D7, if it is 0, it is memory reference instruction. If my D7 is 1, it is register input output instruction. We'll look into what is memory reference and register input of instructions in the later part. Okay. So here when my D7 is 0, it means memory reference instruction. When it is 1, it is my register input output instruction. right? After that, I'll come back to my I flip-flop, indirect or direct. If I is 0 here, in register case, in register input output case, it is register type instruction. If it is 1, it is input output instruction. So, my execution of the instruction will be performed at timing T3. Timing T3. So, this is my input output instruction. I will execute my instruction here and again I will make my SC to 0. After that, my programming will be, again my process will be from starting. It goes to starting point. The same case here. If it is 0, it is not our input output, it is register instruction, register reference instruction, and my SC is set to 0 and again it is to first part, that is fetching. Now coming back to here, whenever my memory D7 is 0, it is memory reference instruction. In again memory reference instruction, we already seen two types, direct and indirect addressing. If my I flip-flop shows 0, it is direct addressing. In direct addressing, at time T3, it does nothing. That means nothing, there is no operation at this stage if direct addressing is given. Okay, but it increments the SC value so that other timing signals will be available there. Now here, if it is 1, it is indirect addressing. Whenever we come across indirect addressing, we need to read the effective address, right? So we are reading the effective address of the register given. Then after that, executing this is memory reference instruction. So executing memory reference instruction, setting my SC to 0. Again, the program shifts or it goes back to the starting position to T0, fetching. Okay. Now, if we see the micro operations here in a line format, then it will be, see, whenever D7 is 0, that means D7 or will come from 1. Whenever D7 is 1, it is D7 and my I is 1. I is 1 and the timing is T3. In this period, T3 will be active. In this determining, whenever we determine a type of instruction, the timing signal T3 will be always active. So, whenever my D7 is 1, this shows by D7 and this is my D7 complement, that means 0. Okay. Whenever my DC is 1 and I is 1 and T3 is the timing signal, what I am doing is executing input output instruction. Executing input output instruction. Now, whenever my D7 is 1 but my I is 0, T3, then I am executing register reference instruction, right? Then again, whenever my D7 is 0 complement and I is 1, my I is 1 and at time T3 I am executing memory reference instruction. Right? Whenever my D7 is 0, even my I is also 0, at time in T3 I am doing nothing. The instruction is nothing. Okay? So, this is how we determine the type of instruction that is executed. Whenever the execution completes, it automatically at every stage SC is set back to 0. So again, it is going to the first stage, that is fetching, for the next instruction to complete. Now, we'll learn about what are register reference instructions, what are memory reference instructions, what are input output instructions in the later video. So this is how an instruction cycle is divided, and it is worked by divided into 4 parts. Okay. Once again, the review. Here at T0 we are fetching, here decoding, here reading effective address if any indirect address is present, then at T3 we are executing, then again going back to the fetching stage. This is how an instruction cycle is worked. Thank you. That's all for this video.